number? Huh? Okay. Exactly what I just said. I told you that people are going to ask me some question. Okay. 13, put in 13 first, okay? Let's go to math together. Math. Are you there? Then go to PRB. R to PRB. Are you there? This is factorial. The exclamation mark is factorial. The exclamation. Because see, we did it before, I know. And actually, somebody emailed me and told me that we never did 6.4. Guess what? That's why I'm recording I'm recording it. Because now, if after you teach somebody and the person is not in class or not paying attention, they say we never even touched 6.4. I have never had factorial. And the person had the gut to tell me that we never did it in class. Well, I didn't argue that. I've never had combination in class. So guess what? After recording it, I put it in. And so if you say you haven't had it, then you see it in the video. All right, so I'm going to select 4. So, and then I will enter. And then let me see how many millions that is. So if I start from the back, after every 3 digits, I put a comma. So that's a comma after 8. Then I come after 2. And then that is going to be about 6 billion, something like that. But the important thing is that make sure you use commas to separate. Sometimes you'll be told to leave your answer in scientific notation. Somebody's trying to see if you still remember your middle school maths. Leave your answer in scientific notation. Okay, so you can do that. All right, this looks like a test question. So let's keep going. So somebody's going to test and see if you know how to use your. All right, so a lot of these questions on testing a whole lot of things. I tested the OR probability. Remember that there are 2 OR probabilities. And OR probability can be mutually exclusive, which is the same as disjoint. Let me make sure we remember. So if I'm told to use OR probability, or there are 2 of them. The first one is P, A, or B, let me just use union. Or and union are the same. Is equal to PA, probability of A, plus probability of B. Because the intersection, there is no intersection. If you're told to draw a Venn diagram, forgive my crooked Venn diagram. So this is my A or B. Let me ask you a question. Is this mutually exclusive? Is this a mutually exclusive? No, because they intersected. They are not supposed to intersect if it is mutually exclusive. There shouldn't be any common area. So if I'm told to draw it, even if I'm not told to draw it, if I'm showing my work, I better show that I understand what mutually exclusive are. They have no intersection. So this is A, and this is B. Okay, so this is all probability disjoint. There is nothing in common. Therefore, PA intersection B is 0. PA intersection B is equal to a null set. Let me use a null set here, or 0. Okay. So now you can, so let's go back and see what that question says. Let's go back and see what the question says. All right, so first of all, this is checking that you remember your middle school sets. Okay, set. Okay, a probability experiment is conducted in which the sample space is all the numbers listed in that braces, and event F is 11, 12, 13, 14, 15, and event G. So there are 2 events, And now we're going to have a compound event. So be careful. When it's a compound event, you can have or. And the question, if the question says and, they got to be careful. And the question can say, it can be conditional. So if you have two events, then expect to have or, which is addition, and the or could be or mutually exclusive, or the or non-mutually exclusive. Okay, let's continue. Assume that each outcome is equally likely. So if equally likely means any one of them can happen, they have equal probabilities. List the outcome of F or G. First of all, I want to know if I'm doing F or G, I want to know if there is any member of F and G. Is there any common member? Let's see. It seems like there is 15 here in F and there is 15 in G. What is ruled out right now? Because they have a common member, something is ruled out. Because they have a common member, it's not mutually exclusive. Is that clear? Because F and G do have one number in common, it's not mutually exclusive. Not. So it is joint. So I'm going to draw a picture. If I'm answering a question, I draw a picture. And I will show a joint probability. And let me call this one F. And I'll call this one G. And which one is common? 15. I'll go to that middle and put 15 in there. I'll go to the middle and put 15 in there. And since 15 is in there, the other members of F are 11, 12, 13, and 14. 13 and 14. All right, then I go to G, the other members of G that are not in F are 16, 17, 18. 16, 17, 18. Okay. And now I am told to find, by the way, how many, look at the sample space here. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 of them. Let me go to find the probability of F individually. Probability of F is, how many are in F? 1, 2, 3, 4, 5. 5 out of 12. Do you agree? The probability of G, how many are there? They're equally likely. They are all equally likely. 4 out of 12. All right. What is probability of F intersection G? What is the and? The probability of F intersection G is 1 out of 12. Do you agree? Do you agree? This looks like a test question. Okay, now I want to do all joint events, all non-mutually exclusive events. So I'm going to write the formula. P, probability of F or G union G, or can be represented with U, union, is equal to probability of F plus probability of G minus probability of F intersection G. F intersection G. Come on, do that. F intersection G. Let me come over here and write it. So that minus P probability of F intersection G. All right. And I have them all. I have already calculated them. So probability of F or G, which is a joint probability, is, I already have them. So P F union G is equal to 5/12, 5 out of 12, plus 4 out of 12, minus 1 out of 12. So when I add all of them, when I do the math, I have 9 out of 12 minus 1 out of 12 is 8 out of 12. Therefore, the R probability, the non-mutually exclusive probability is 8 out of 12 or 2 out of 3. So 8 out of 12 or 2 out of 3. You could be told to leave your answer to 2 decimal places or 3. That means you have to change 2/3 to decimal. So let me check. Type an integer or a decimal rounded to 3 decimal places. So I have to change it to 3 decimal places. So 0.667 to third. If I use my calculator, I have 0.666, right? But the instruction says leave my answer to 3 decimal places. So I'm going to have 0.667. Do we agree? Does it make sense? Hello? Any questions? Okay. Let's continue. I'm going to clear. And so for people who did not come to class, I'm recording this. I will put it in. I'll put the recorded lesson in review in. Now I think I'll be doing it all the time because of people who just go ahead and say what they like. Okay. So P, A, or G, we have already found that. And we already said it is A. It's not an empty set. Now let's go to the other section. Determine P, F, or G using the general rule. We have already written the general rule. The general rule is the joint rule. The general rule for all is the joint rule. I can write it again. Select the correct choice below and fill in. Okay. So P, A, or G. Let's see. This is actually wrong because P, A, or G. That's not the formula. I want you to see what is going on here. They put actually, let me clean it. Let me clean so I can put the right one. A is the mutually exclusive, and it is not mutually exclusive. Okay, so the non-mutually exclusive is here, and P, A, or G is probability of F plus probability of G minus probability of F intersection G, which means F and G, and then you get your answer, whatever your answer. And we already did get an answer, which is 2/3. Question? Any question? All right. All right. So let's go to. I don't have to follow it. I don't have to. All right. A question can be asked in so many different ways. So a question can be asked. Look at the same kind of question in number 9. They just want to see if you understand the question. A woman, look at number 8. A woman has 3 skirts and 4 blouses, assuming that they all match. How many different skirts and blouses combinations can she have? Can she wear? All right. If they all match, 4 blouses. Well, you can actually use but this is easy. You can just say 3 times 4. There are 3 times 4 different ways. That is 12. You could be told to draw a tree diagram. So you could told to draw a tree diagram, but this time they didn't tell us to draw a tree diagram. Because we don't have time, I don't want to be wasting time drawing a tree diagram. But you could be told to list it. Okay. So let me try and draw a tree diagram. When time is up, I want you to know there are some repeated questions here. So if you do one and you know it, we don't have to do the repeated question. So suppose the skirts are S1, S2, and S3. I'm trying because you might have, yes, you see a question like this anywhere. And then blouses is B1, B2, B3, B4. But it's talking about skirts first. So I am going to do the blouses now. For each skirt, I can match it with the blouse. There are 4 blouses. So B1, B2, B3, B4, B1, blouse 1, B2, B3. If you're told to draw a tree diagram, by all means, this is what they want you to draw before. And then also here, B1, B2, B3, B4. And so that's why you count the final branch. This is 4 plus 4 plus 4. That is how you know that the sample space is 12. The sample space is 12, or 3 to the power 1 times 4 to the power 1, which is 12 also. If you're told to list it, skirt number 1, blouse number 1, skirt number 1, blouse number 2. You're not told to list it anywhere. Skirt number 1, blouse number 3, and you finish with this branch, and you go to this branch. Come here, you say skirt number 2, blouse number 1, and so on. Because you might be told to list them. Then you will list them. Okay, I don't want to waste time drawing tree diagram, but I hope you catch the game. I'm going to quickly go to some others. I don't want to do all of them because it's not going to be a review anymore. It means spoon feeding. But anything that, but I just want to let you know that some of those questions you said we did not do, you just haven't looked it up. It's not going to be a spoon feeding class. You have to do some, and then I do some. If there is a question where we don't agree, trust me, if there's a question you don't agree and I do it, I notice there's a discrepancy, I don't even put it in a test. Or if I do, then I give credit to everybody that tried that question. So if during a test and I give a question and everybody complained about that, if everybody in the class finds a fault in one question, then something is wrong with that question, trust me. So if everybody finds a problem with one question, then we are going to ask. Sometimes I ask the author. Before the author answers the question, I want credit for that number, because the author shouldn't be giving us questions that is confusing to everybody. By the way, the author is a human being. The author can make a mistake. So if one question throws everybody in my class off, that question is better going to be rolled out. Trust me, I do that all the time. Okay. All right. So question number 9 looks like all we have been talking about. Find the probability of the indicated event PE. So remember, we are given some probabilities. Probability of E is 0.4. Probability of F is 0.4 also. Probability, the intersection. So the intersection of, okay, well, let's look, let me read it very well. Let's read it. All right. If P or F is 0.75, well, they're asking you the general rule or indirectly. Do you actually know this formula? Because calculator will not do everything for you. Do you actually know the rule the OR rule general formula. Okay, so you write the OR rule general formula. So you if I were you, I'm just going to put the general formula here in my paper. So P E union, because the OR rule is OR. So union P E or F is equal to probability of E plus probability of F minus probability of the intersection minus intersection PE intersection F. Well, let's see what we are given. We are given some things. So we are given that PE is 40%. So 40% is 0.4. And we are given that PF is 40% also, 0.4. And we are told to find the intersection. So we are looking for PE intersection F. So we don't know it. But we are given the OR, PE or F. So on this side, I have, this is just simple algebra. But somebody wants to know if you know a formula though. Somebody's trying to see if you know the formula called general formula for OR. So all you have to do is solve the problem. So 0.75 is equal to 0.8 minus the intersection. Well, I wanted to see that this is minus. So if I say minus 0.8 on both sides, minus 0.8 on both sides, I will have minus 0.0, okay, yeah, 0.05. Minus 0.05 is equal to minus the intersection. Divide both sides by -1. Therefore, the intersection is 0.05. Therefore, PE intersection F is 5%, 0.05. Question? Question? Looks like a question. See, I can take any 15 questions from here. I can take any 15, and I give it to you 1 week ahead. Trust me, 1 week ahead. And because it's unit 3 and unit 4, so first week of unit 4, I'll give you the practice tests. Before unit 4 is over, I'll give you final exam practice. If you actually study them very well, you are making A's all through. But if you wait until a day to the test, trust me, that's not how to pass probability and statistics. You can cram this course overnight. You cannot cram it. You have to be doing it gradually, sequentially. Okay, and it's not about saying, okay, well, she did not teach me that. I don't care what you said. I have taught this class for 40 years. So if you pay attention, you make an A. It's simple. If you don't, you make a C or even a D. It's as simple as that. It's just not saying, oh, she didn't teach it. That doesn't solve the problem. You can go and study. In fact, whatever you don't know, why don't you go to YouTube and Google it? Instead of trying to blame somebody, why don't you go, if you go to YouTube, you can learn anything, whether it's in your book or not in your book. And so defending your defensive mechanism doesn't help anybody though. Anyway, okay, so I am going to clear, and let me see if you can answer the question number 10. Somebody, question number 10. How do we answer question number 10? And what kind of question is this, by the way? 6.4, one that said we did not do. I had it from so many places. She did not teach 6.4. So, okay. A salesperson must travel to 10 cities to promote a new marketing campaign. How many different trips are possible if any route between cities is possible? I think I'll have passed 10 minutes. I'm going to stop recording. I'm going to start. Okay, so Aaron, we have just agreed that Aaron will do it in 13 factorial number of ways. So I'm going to get my calculator. Well, good thing is that you are allowed to use your calculator on the tests. So I am going to put 13 here. Does anybody still remember where to go to get factorial? Yes. No. Thank you. Very good. Very good. I just gave a test this morning to a class, and somebody said, "Can you tell me where to find the probability?" I said, "This is a test." So on test day, that's why I'm reviewing. That's why I'm doing what I did before. On test day, you're not going to ask me where do we find permutation or combination, because that is what we are testing. Are you there? On test day, that's what we are testing. So you're not going to ask me on the test day, I forgot where to find combination. I forgot how to do it with my calculator. No, that's what we are testing. That's why I'm going over what we have done before. That's why it's called a review. So 13, I'm going to go to math, probability, and look for factorial. There are 13 factorial number of ways that Aaron can do that. And that's a large number. Okay, all you have to do is collect this